Hey everybody, this is Mr. Tui here from mtcollegeprep.com, and we are going to be working on SAT practice test number 1. That's section 3. This is the no calculator section. And I'm going to do a little experiment today. I'm going to try to solve these questions, all 20 questions in section 3, within the allotted time, 25 minutes. So we're going to do this fast and furious. I'm going to show you the easiest way to solve all these questions. So let's start. I got the timer going. We've got 25 minutes. Let's begin. All right, question number 1 reads, if x minus 1 over 3 equals k, and k equals 3, what is the value of x? All right, there's an algebraic way to solve this. You can do it, but there's an even easier way to do this without worrying about an algebraic operation, and that's just to test the answer choices, man. Plug in the answer choices for x, and we know k is 3, so let's do that. I'm going to test answer choice A. We're going to get 2 minus 1 over 3 equals 3. That's crazy because that's 1/3, which doesn't equal 3, so we know answer choice A is gone. Let's test answer choice B, 4. So we've got 4 minus 1 over 3 equals 3. That's also crazy because we know that 4 minus 1 is 3, and 3 over 3 is 1, not 3, so answer choice B is gone. Answer choice C is 9. We're going to test that. In fact, I'm just going to plug in a 9 right here. 9 minus 1 is 8 over 3. That doesn't equal 3. 9 over 3 would be 3, but not 8 over 3. So it's not answer choice C. It's got to be answer choice D, 10. Let's test it, make sure it's right. And plug in the 10. 10 minus 1 over 3 does, in fact, equal 3 because that's 9 over 3. 9 over 3 is 3. So we can confirm it's answer choice D. Blammo! Let's move on to question number 2. Question number 2 reads, for I equals the square root of negative 1, what's the sum of that whole thing? Okay, great. So this is just combining like terms. That's all they're testing you on here. And some of the imaginary number questions on the SAT can get a little bit tricky, right? You got to remember that I squared is negative 1. If you're not familiar with that, look it up. But anyway, that's the thing. But here it's just combining like terms. So we can deal with I just like we deal with X. So all we're doing is combining like terms. Real easy. So we know 7, I can combine the 7 and that negative 8. That's going to give us a negative 1. Now I combine that 3i and the 9i. We just add those together. I don't have to distribute any negatives or anything fancy like that. That's going to give us 12. And that is not 12. There we go. 12i. And it is indeed answer choice A. All right, rock and roll. Let's keep moving. All right, question number 3. On a Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? We can think about this in terms of algebra. We can do that. That's a thing, you know. And if you're really comfortable with that, maybe you can just kind of look at this and figure out what the right answer is. And that's cool. There's another way to do this too, where we can just plug in the values, right? Instead of dealing with M and P, we can turn M into a value, right? So I'm going to do that. I want to turn M into, well, let's make M equal 1. And we're going to make P equal 0. And when we do this, we can reread this question, right? Armand sent not M text messages, but 1 text message each hour for 5 hours. And Tyrone sent P text messages, that's not P text messages, 0 text messages now each hour for 4 hours. And the question is, what's the total number of messages they sent, right? So if Armand sent sent 1 text message each hour for 5 hours, he sent 5. And then if Tyrone sent 0 for 4 hours, he didn't send any. So the total is going to be 5. All we got to do now is just plug in these values for M and P into the answer choices. Woo! And look and see which one gives us 5. A doesn't give us 5, that gives us 0 if we plug in those values for M and P. Answer choice B also gives us 0, so that ain't right. Answer choice C, I mean, if we want to do it, we can plug it in. Let's plug in the 1 for M, so we get 5 times not M but 1, plus 4 times not P but 0. That does indeed give us 5, because we get 5 plus 0. And then look at answer choice D. I'll plug in my M and P values for that. Again there. So we get 4 times 1 plus 5 times 0, which is going to be 4, not 5, and we know the total has to give us 5. So we know it's not answer choice D. We can confirm it is indeed answer choice C. Woo! Let's move along to the next question, question number 4. All right, question number 4 reads, Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she's worked that week. What is the meaning of the value 108 in this equation? All right, I coach a lot of students to underline the last sentence of every question. right? Because that's the thing you're solving for. We're trying to find the meaning of the value of 108 in this equation. A couple ways to look at this. I really recommend that students kind of look at the answer choice of word problems on a purely logical level, right? Like, let's go through them and see if we can eliminate any that just don't make a whole lot of sense in the real world. All right, so let's test the answer choices here just kind of on a basic logical level. So answer choice A reads, Kathy will complete the repairs within 108 days. Is that the meaning of the value 108 in this equation? Is that possible? I guess that's possible. That sounds like a long time, right? I'm a little bit suspicious of answer choice A. It's a long time to be completing the repairs. So let's look at answer choice B. Kathy starts each week with 108 phones to fix. Could that be a thing? Could somebody have a job where they've got 108 phones to fix in a week? I guess that's possible. Let's keep it as well. All right, I'm a little less suspicious of B than A. Answer choice C. Kathy repairs phones at a rate of 108 per hour. Okay, think about that for just a minute. 108 phones in an hour. Okay, so we're talking about more than a phone per minute, almost 2 phones per minute, right? It's like a phone every like 35 seconds she's fixing. That sounds pretty crazy. I just don't think that would work in the real world. I can eliminate answer choice C pretty easily. Answer choice D. Kathy repairs phones at a rate of 108 per day. That's also a lot, right? She's working an 8-hour day. We're talking like 12-ish phones per hour. So that's like a phone every 5 minutes or something like that. That's pretty fast. It might be possible. Maybe we can even keep it. But I'm suspicious of A and D. B sounds pretty reasonable. There's another way we can look at this. It is answer choice B, by the way. Another way we can look is we can plug in values. Once again, like we did before. You don't have to deal with variables. You can deal with actual values. So let's plug in a value for D into this equation right here. And I think that's going to clarify things a little bit, right? So we're going to plug in a 1 in for D. So we'll say P equals 108 minus 23, but not times P times 1. We're plugging in a 1, right? And think about this for just a minute. We're not just making D equal 1, right? We're going to find out how many phones she's fixing in 1 day of work, right? Or how many phones she has left after 1 day of work, right? That's what this means here. D equals 1. She's worked 1 day. How many phones does she have left? So we plug that in and we get P equals 108 minus 23, which is going to be like 85. So she has 85 phones left to fix after 1 day. Okay? Let's make D equal 2. Let's see what happens. We can kind of play with this. And we get P equals 108 minus 23, not times P, but times 2. Okay? We're just creating a real value for these variables. And we'll get P equals 62. So at this rate, so she worked 1 day, she's got 85 phones left to fix. She's worked 2 days, she's got 62 phones left to fix. It's not going to take her 108 days to fix these phones. So I feel pretty comfortable eliminating answer choice A. And we know she's not fixing 108 phones per day, right? Because I'm looking at this now and I see she's fixing like 23 phones per day at this rate, right? Which now we can see where that 23 in the equation comes from. That's the number of phones she's fixing every day. So D is gone. And I can confirm this by plugging in a 0 for D. I'm going to make D equal 0, which means she hasn't worked any days yet. So P equals 108 minus 23 times 0, not D, right? And that means she's worked 0 days. She's got 108 phones left to fix. That's exactly what answer choice B is saying. Kathy starts each week with 108 phones to fix. Blammo. 4 is done. Let's go on to the next one. Oh, yeah. All right. Get the timer going again there. All right. Let's look at question number 5. Which of the following is equivalent to the expression above? A lot going on here. This is also, it's similar to question number 2, right? It's a combining like terms question here. Now, the tricky part here is we got to make sure we've got this term in parentheses on the right-hand side. We got to make sure to distribute that negative sign right there in the middle, okay, to all the terms on the right-hand side. So I'm going to rewrite this as x squared y minus 3y squared plus 5xy squared. This is not super purple rewriting that when I'm doing it, but it's going to be plus x squared y minus 3xy squared, distributing that negative sign, plus 3y squared. Okay, so I like to use a method here I call underline, combine, and scratch out. So I'm going to underline the like terms here. So we got x squared y here, x squared y here. Remember, there's a coefficient of 1 in front of those guys. Coefficient 1, it's kind of hidden there. Coefficient 1, so I'm going to rewrite that as, so I've underlined, I'm going to combine them. I'm going to get 2x squared y from those, and I'm going to scratch them out completely. I don't even want to look at them. They're done. We've used them already. Okay. Now let's underline two more like terms. I've got 3y squared and negative 3y squared. Those are going to cancel each other out. That's going to leave me with nothing. So, anything plus its opposite is going to be 0. So I don't have to worry about those. Just scratch them out. Right? Like 1 minus 1 is going to be like nothing, and 2 minus 2 is going to be nothing also. I've got two more like terms here. We've got negative 3xy squared and 5xy squared. So you just add the coefficients, and you're left with 2xy squared. Those are gone. And that matches up with answer choice C. So we're good there. Ta-da! Found the answer. All right, great. Question number 6. I like this one a lot. Question number 6 reads, we're doing this fast. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay, so let's stop. Let's underline exactly what we're solving for, right? We're solving for the estimated increase in inches of a boy's height each year. The thing you're solving for is always in the last sentence of the question, okay? It's estimated increase in inches each year between the ages of 2 and 5, okay? Let's look at this logically, kind of like we looked at number 4, just on a purely logical level. How much is this kid growing every year between the ages of 2 and 5? And take a look at the answer choices, man. They're freaking crazy, some of these, okay? On a logical level, all right? Look at answer choice D. 14.3 inches. Is there any way a kid is going to grow 14.3 inches per year between the ages of 2 and 5? Think about that. You're going to be dealing with like a 6-foot-tall 5-year-old, something like that. That's every parent's nightmare. That's crazy. That's awful. It's a really dumb. It's laughable. If you think about it logical, it's laughable to even put it on there. Answer choice D is gone. Even answer choice C is silly. 9.5 inches. That's like 10 inches per year. Kid, he's still going to be. You're going to talking like a 5-foot-tall 5-year-old. That's bad enough, man. That's huge. There's no way. You don't even have to just think logically here. These are real-world questions, and the solutions have to work in the real world, too. There's no way to answer choice C. Just guessing here at this point. You guess between A and B, you got a 50-50 shot. Those are pretty good odds. On a tough question. This is not an easy question, okay? But we can find the answer by plugging in values, once again, in place of the variables, okay? We're trying to find how tall this kid is between, or how much he grows every year between the ages of 2 and 5. So let's find out how tall he is when he's 2. We can find that really easily by plugging in 2 for A, right, into the equation. That also has his height when he's 2. So let's do it. So his height when he's 2 is going to be 3 times, not A, but 3 times 2 plus 28.6. That's going to go to 6 plus 28.6 is going to be 34.6. So when he's 2, he's 34.6 inches. Okay? Let's find out how tall he is when he's 3. We'll find the increase. So H equals 3, not times A, but times 3 now, because he's 3 years old now, plus 28.6. So we get H equals 9 plus 28.6. He is now 37.6 inches. What's his increase there? Well, that's 3 inches, which would be answer choice A. That looks good. And we could plug in again at 4, see how tall he is when he's 4 and see what the increase there, but I promise you it's going to be 3 again. Don't have to think in algebraic terms, think in concrete terms and plug in those values. Almost always, almost all the questions in the SAT, there's very few that require specific algebraic operation. Think in concrete terms, deal with real numbers. All right, make it real. Good, we got number 6. Number 7, let's do, this one is tricky, man. This is a tricky one here. Let me show you how to do it. All right, so we've got this giant messy fraction right here. This is the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months, which of the following gives P in terms of M, R, and N. Okay, so what do we solve for here? We're trying to find P in terms of M, R, and N, which is kind of a fancy way of saying isolate P. Okay, that's kind of what they're looking for. You see this wording on the SAT a lot. All right, which following gives this variable in terms of the other variables. Okay, and you look at the answer choices. All of them have P isolated on the left-hand side. So that's kind of what we're trying to do here. All right, a couple ways we can do this. I'm going to start by eliminating some using some basic logic. Okay, and you ask yourself the question, can I cancel anything out in this messy fraction up here at the top? Can I cancel anything out? And if you know anything about sort of like basic math operations and arithmetic, you realize you can't because there's this -1 right here. If there was no -1 there, you could cancel out the 2 big chunks in parentheses at the top. You could cancel those out. But you can't do that. Don't do that. Can't do that. And knowing that you can't cancel anything out just like that, you can eliminate 2 answer choices. Right off the bat, you can eliminate C and D. Gone. You don't have to worry about them. All right? You can't cancel things out with this. All right? Then, is it going to be A or B now? And if you look at A is just like, all they did is they took the P and the M and they just switched them. Which, if you know anything about algebra, again, you just can't do that with variables. And at least B is rearranged a little bit more, so that's a possibility. But it can't be A, because you can't just move this one to the side, move this one to the other side. You can't just do that. So it can't be A. Okay. Another way to look at this, B is looking good, by the way. Another way to look at this, we can confirm B, by the way, it is going to be B, is look at this fraction as if it were a simpler fraction. It's just a fraction, but like I could rewrite it as m equals A over B times P. Okay, m equals A over B times P. All right. And notice it's the exact same form. It's just m equals some fraction times P, right? And they're asking us to isolate P, get P alone. Well, just multiply by both sides by the reciprocal, right? Of A over B, which is B over A. So we got m, P equals, let's cancel out there, P equals m times the reciprocal of that fraction. That's answer choice B, blammo. We got it. SAT isn't too bad. Don't be intimidated by these scary looking questions. They love disguising relatively easy concepts as very difficult questions. They love doing that. But don't be intimidated by this. It's testing your isn't as hard as everybody thinks it is. Just got to look at it the right way. All right, that's 7? I think that's it on that page. Great. Let's keep on rock and rolling. Let's go to question number 8. All right, question number 8 is, if A over B equals 2, what is the value of 4B over A? Looks super scary. Don't be intimidated by this again. We can plug in values and place the variables. Create values for A and B. I'm going to make A equal 2. I'm going to make B equal 1. That's it, right? And you can pick any values. You could make A equal 4, make B equal 2. You can make A equal 8 and B equal 4. It doesn't matter as long as A divided by B gives you 2, right? You can't pick 3 and 3 because that wouldn't give you 2, right? 3 divided by 3 isn't 2. As long as A divided by B equals 2, you can pick anything you want. And I'm just going to plug those values right there back into the expression of the question. So I'm going to rewrite it as 4, not times B, but 4 times 1 over not A, but over 2. And that just gives me 4 divided by 2, which is 2. There's answer choice C. Be aware, too, they love hiding the answer in the question. They love doing that. Just be on the lookout for that. That's something that pops up actually on this very practice test. We'll see that in a little bit. Question number 9. What is the solution, x comma y, to the system of equations above? Ooh, we got systems of equations. All right, a couple ways to look at this. You may be familiar with the elimination method of systems of equations. There's also the substitution method. Just look those up on YouTube if you want to know how to do those. About half the questions on the SAT with systems of equations, you're going to need to use the elimination method. That's the one I really recommend. They're generally kind of set up for that. Here we don't have to do any of that because look at the answer choices, man. Look at the answer choices. Those are our x and y values, man. We can just plug those in for x and y, turn this whole thing into arithmetic. That's all we have to do. We don't even have to do a specific algebraic operation. I don't recommend it. Not when they give you the values. So let's just plug those in for x and y, right? This is your x value right here. This is your y value. It's an ordered pair, right? X comma y. So I'm going to test the answer choice. I'm going to plug in -5 for x. I get 3 times not x, but times -5, plus 4 not times y, but times -2, and that gives me -23, apparently. I'm going to test this here. I get -15 plus -8. That's looking good. That does equal -23. So that's looking good. I got to test the bottom equation, though, now. And I'm going to plug in that -5 again for x, but I've got 2 times y, but it's not y here, it's -2. Minus x. X is -5. That's supposed to equal -19. We'll see if it does. We get -4 minus -5, which is plus 5. That's not going to equal, that doesn't equal -19, so I don't have to worry about answer choice A. It's gone. The arithmetic doesn't work out. Let's test answer choice B, which I think it is. Don't worry, I'm not going to have to chew through all these. But let's test it. So answer choice B, we got x is 3, so it's 3 times not x, 3 times 3, plus 4 not times y, but 4 times -8. That's supposed to equal -23. I get 9 plus -32. That's looking good. That does equal -23, so I can confirm the top equation. Let's do the bottom one. We got 2 times -8 minus, not x, but -3. That's a really ugly 3 there. That's ugly too, that's right. That's supposed to equal -19. I get -16 minus 3. That does equal -19. I can confirm it is indeed answer choice B. Done. Don't even worry about the others. Moving on. Woo! Question number 10. For the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of -4? I could spend some time talking about kind of functions and how function works, function notation works, and all that. All you got to know is when they say, what's g of -4? right? All that means is where there was an x, we're now going to plug in a negative 4, right, into the function. So right here, we're trying to find that. But we're not going to be able to find that what that is until we know what a is. So so we got to find a. Now they tell us that g of 4 equals 8. So I know when I plug in a 4 for x, I get 8 as an output for that function. Okay? So I can set up an equation here pretty easily. All right, g of 4. All right, now where there was an x, I'm going to plug in a 4 equals a times not x squared, but 4 squared plus 24. Okay? That's just kind of how functions work. I've got some videos on functions you can check out on the old YouTube. I think. So check them out. But anyway, I can get in more detail with that later. So g of 4 equals, okay, great. So now, but I know what g of 4 equals, right? That equals 8, so I can just replace that with an 8. So 8 equals a times 4 squared, that's 16, plus 24. Just doing some basic algebra here. I'm going to try to isolate a to find out what a is. Subtract 24 from both sides. I get negative 16 equals a times 16. So a has to be negative 1. Yay! So I know a equals negative 1. I can plug in my negative 1 for a now. Woo! Erase that. Plug in negative 1 for a. I'm going to still try to find g of negative 4. So g of negative 4 equals, I'm going to plug in negative 1 for a, woo, times negative 4 squared plus 24. Find out what that is. Just arithmetic here. Negative 4 squared is going to be 16 times negative 1 is negative 16. So negative 16 plus 24, g of negative 4 equals 8, which is answer choice A. And notice, by the way, they hid the answer in the question once again. They love doing it in the SAT. Just be on the lookout for that if you're guessing. Another way to look at this, just be aware that x squared up here in the function, x is being squared. Okay, so just x squared by itself is going to be positive. There's no way it's going to be negative, right? So 4 squared is going to be the same as negative 4 squared, right? So g, by definition, g of 4 is going to have to be the same as g of negative 4, just by definition. So that's another way to look at it, sort of logically. It took me a couple years to realize that, but you don't have to work this out and solve A if you don't want to. But anyway, another way of looking at the question. I'm going to roll because I'm trying to finish this in time. May not happen. We're still going fast, though. We're going fast. Question number 11. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during the summer. What is the price per pound of beef when it was equal to the price per pound of chicken? Let's clarify what we're solving for. Again, I'm going to underline the last sentence in the question. What was the price per pound of beef when it was equal to the price per pound of chicken? So we're trying to find when B equals C. When the beef price equals the chicken price for some number of weeks, X. Okay? And I'm looking at the answer choices. They're all relatively small values, right? We're not talking hundreds of dollars here, right? We're talking the highest value is $3.35, which means X is going to be a small value. In fact, X can't be bigger than 4, because I'm looking at that top equation right there. When X is 4, that would give me $3.35. So it's got to be something between 0 and 4. 0 won't work, because if I plug in a 0 for X, right, we're talking about X weeks, right? I'm just going to plug in values there. I could set both equations that equal each other and do the algebra here, but let's just deal with some basic arithmetic instead. If X is 0, I get beef price of $2.35 and a chicken price of $1.75. So I don't have to worry about 0. I'm going to plug in a 1. And so if X is 1, B is going to be, the beef price is going to be, let me see, I'm counting change here, man. This is money. This is easy. I think I get $2.60 for the beef price, okay? And the chicken price is going to be $1.75 plus what is going to be $2.15. So that doesn't work, right? So X can't be 1, and by the way, it can't be answer choice A, because when beef is $2.60, chicken's not $2.60. So that's gone. Let's plug in a 2 for X. So I get $2.35 plus 50 cents now, right? It's 2 quarters when X is 2. And that gives me $2.85. So the beef is $2.85 when X is 2. And the chicken price is going to be $1.75 plus 80. I mean, I'm counting change. Plus $1 would be $2.75 minus 20. It's going to give me $2.55. So it can't be, X can't be 2. It's going to be either 3 or 4. And it's not going to be answer choice B, because when beef is $2.85, chicken's not $2.85. Let's plug in a 3 for X. Let me see. I get beef is going to be $2.35 plus 75 cents. It's going to be $3.10, which isn't even an answer choice. So I don't think I'm too worried about that x being 3. Let's check x is 4. We already discussed this. When x is 4, the beef price is going to be $2.35 plus $1, so it's going to be $3.35. The chicken price is going to be $1.75 plus $1.80. Ooh, I might have to write that one out. Did I say $1.80? Is that right? 1.64, $1.60. 60. 5. That's going to be 3, 1, 3.35. Hey, we get the same value when x is 4, so I can confirm it's indeed answer choice D. Done with 11. Don't get fancy with the algebra if you don't need to. Just use common sense and logic. Plug in values. Question number 12. A line in the xy plane passes through the origin. That means the point 0, 0. It's right kind of the center of an xy axis. Passes through the origin. Got to know that term. And has a slope of 1/7. Which of the following points lies on the line? Everybody wants to pick B here, and they're all wrong. Just, guys, if they give you a graphing question, just graph it, man. This is not difficult to graph. Just freaking do it. So let's graph this, all right? So here's, we know it goes to the origin, so that's the point 0, 0. It's going through that. It has a slope of 1/7. Well, you guys know what slope is, right? Slope is rise over run. So we're going up 1/7. Rise is 1/7. 1, 2, 3, 4, 5, 6, 7. This is an ugly graph. I don't care. It's going to work. There's our line. We got 2 points. We got a line. Woo! Something like that. Okay? All right. So which of the following points lies on that line? That is the question. And let's test the answer choices. Is 0, 7 going to be on that line? Well, where's 0, 7? That's where the x value is 0 and the y value is 7. That's going to be like up here. So that's definitely not on the line. It's not answer choice A. Answer choice B is 1, 7. That's up here, where the x value is 1 and the y value is 7. It's not answer choice B, the one everybody picks. Don't do that. Graph it. It's obvious. It's not B. C is 7, 7. So the x value is 7, the y value is 7. That's going to be like up here. Also not on the line. I hope it's D. That's 14, 2. At least that could be right. So it's going to be like over here. Something like that. It's at least close, and the others aren't even close. We can confirm it's indeed answer choice D. If you can graph it, freaking graph it. Do it. Question number 13. Oh, I've got like a minute left. That's all right. We're gonna keep rolling. I like this pace. Question number 13. If x is greater than 3, which of the following is equivalent? You gotta know what equivalent means. Equivalent just means equal to, right? Which of the following is equivalent to that messy, scary-looking fraction. All right, there's a big, complicated algebraic way to do this. We don't have to do this. Anytime they ask you about equivalent expressions, okay, which is equivalent, right? This big, messy fraction is going to equal one of those answer choices. You're going to always plug in a value for the variables, always, when they say it's equivalent. And this is the only time, also, we can totally ignore what they tell us in the question, the limits that they give us in the question. They say if x is greater than 3. The only reason they tell us x is greater than 3 is because they don't want us to do what we're about to do, which is simplify this with arithmetic. We're going to plug in a 0 for x. All right? We can totally ignore that, right? Because if they're truly equivalent expressions, it doesn't matter what x is. X could be negative a million, and we get a true statement for 2 equivalent expressions. So I'm going to plug in a 0. It's going to simplify this a lot. We're going to plug in a 0 into this expression, find out what it equals, and plug in a 0 into the answer choice and see what matches up. All right, so let's do it. Let's plug in a value. Let's plug in our 0 for x. So I'm going to rewrite the equation in the question. 1 over 1 over, not x plus 2, but 0 plus 2, so that's going to be 2 plus 1 over not x, but 0, so 0 plus 3 is just 3, so 1 over 3. I get 1 over, let me see, 1/2, I need a common denominator of 3, so I'm going to multiply that by 3 over 3. Common denominator 6, I apologize. I'll get 3 over 6 plus 1 over 3, I'm going to turn that into a denominator of 6 right there, but multiplied by 2 over 2, or anything multiplied by 1 is itself, so I'm not changing the value of those fractions, I'm changing the form. 2 over 6, so I get 1 over 5 over 6, right? I'm just adding the numerators and leaving the denominator. Now I'm dividing by a fraction. I got 1 divided by some fraction. Whenever you divide by a fraction, it's the same as multiplying by the reciprocal of the fraction, right? I'm just going to flip the numerator and the denominator, right? So that's the same as 1 over 6 over 5. I get 1 times 6 over 5, which is just 6 over 5, right? Ta-da! All right, so I know when x is 0, I get 6 over 5. Right there. All right, so great. So the right answer choice has to give me 6 over 5. I'm looking at the answer choices right now, and I can eliminate 2 already that I know are not going to give me 6 over 5 just by looking at them without calculating a thing. It can't be C or D, right? Because those aren't even fractions. They're not going to give me fractions. When x is 0. Remember we set that value of x is 0, right? Got to keep that in mind. Don't forget that. X is 0. Okay, look at answer choice A. Plug in a 0 for x. What do you get? You get 5 over 6, right? Because anything times 0 is 0, right? So you get 2 times 0, 0 plus 5. 5 in the numerator for answer choice A, and a 6 in the denominator when you plug in a 0 for x, right? So it can't be answer choice A. When you confirm it is indeed answer choice B, right? Because if I plug in a 0 for x, I'm going to get 6 over 5 right there, right? Because all these terms are gone. Left is just 6 over 5. It's answer choice B. Bingo. No algebra. Woo! Arithmetic. Plug in values for the variables. It's going to make your life really easy in the SAT. All right. Question number 14, if I can find it. Where are you? Question number 14. Oh, there we go. Ah! This one's a little bit tricky, this one here. So if 3x minus y equals 12, what is the value of 8 to the power of x over 2 to the power of y? Yikes. All right, so but look, we can simplify this again by plugging in values in place of the variables. I'm going to plug in values for x and y right here into this equation, or create values based on that equation, right? As long as, I can pick anything for x and y as long as 3x minus y equals 12, I can pick anything. So here's what I'm going to do. I'm going to make x equal 4. I'm going to make y equal 0. Okay, I could pick like a 5 for x and a 3 for y. I could do that. And we'll work out too. We found the right answer. But you want to pick smaller values in general because that's going to simplify things a lot, especially as you're dealing with like zeros and ones. It's great. But here I think it'll work out if I make x equal 4 and y equals 0. We're trying to find the value of this expression right here, 8 to the power of x over 2 to the power of y. So let's plug those in, and I get 8 to the power of not x, but 8 to the power of 4 over 2 to the power of 0. 2 to the power of 0 is 1. Be aware of that. I get into some more detail on that in some of my videos that are available on YouTube. Why that's the case, I don't want to get into it right now. Just know. I hate when math teachers say, just know when you see this. But that's just not the scope of what I'm doing here. I'm just trying to give you the answer explanations as fast as possible here. So just know for right now that 2 to the power of 0, anything to the power of 0 is just 1. That'll work. So that's going to give me 8 to the power of 4 over 1, which is 8 to the power of 4. Okay? So look at the answer choices now. Okay? Look at the answer choice. I got to find the answer choice that equals 8 to the power of 4. And you might be like, well, Mr. there aren't any that match that up. And that's not exactly, at least in the form. Okay? But look, we can eliminate some of these that we know are not going to be equal 8 to the power of 4. One we can eliminate is answer choice D. They're never going to say we don't give enough information. Just that's a distractor. Don't pick that. Right? They're going to put down some tough questions, and you're like, I don't know what to solve. It must be D. No. Just don't even worry about that. In fact, you can eliminate it right off the bat. I've never seen it be a correct answer choice on an SAT practice test, at least. And I don't anticipate that being the case. I also know it's not an answer choice C, right? Because 8 to the power of 2, or 8 squared, right, is the same as 8 times 8. And 8 times 8 just isn't going to equal 8 to the power of 4, because 8 to the power of 4 is 8 times 8 times 8 times 8. So I know it can't be answer choice C. Also, it can't be answer choice B, because that's 4 to the power of 4. And that's just not going to equal 8 to the power of 4. Because 4 to the power of 4 is going to be 4 times 4 times 4 times 4. And 8 to the power of 4 is 8 times 8 times 8 times 8. And this is not going to equal each other. There's no way. And then you might be like, but Mr. 2, it doesn't look like answer choice A, and it's not. But it could be A, right? 2 multiplied by itself 12 times. That's what 2 to the power of 12 means. Could equal 8 times itself 4 times. It could, and it does. In fact, I can show you why. 8 to the power of 4, we can express 8 in terms of 3. Right? So 8 is the same as 2 to the power of 4. So 8 to the power of 4 is the same as 2 to the power of 3 to the power of 4. Ooh, right? So it's 2/3, 2 to the power of 3, multiplied by itself 4 times. That's 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. Some ugly 3s. I have some issues with writing 3s, apparently. Times 2 to the power of 3. That's 12 2s, right? Because 2 to the power of 3 is 3 2s, right? And that 4 times, it's going to be 12 2s altogether. So that's 2 to the power of 12. Booyah! Answer choice A. Answer choice A. 2 to the power of 12. Anyway, I do go over this problem in some other videos, so you can check out a more detailed explanation if you want, but you don't have to. You can do whatever. Yeah, I'm just going to move on. All right, question number 15. Clear some space here. Okay. Oh, yikes. All right. If ax plus 2, that whole messy thing, equals that whole messy thing there. For all the values of x and a plus b equals 8, what are the 2 possible values for c? They'll test you on a concept here that I want you to be aware of. And I call this the matching coefficients concept. Where if I've got some expression where it's like ax squared equals 15x squared. Okay. Well, I know what a has to equal. I've got the same coefficient or the same variable here, x squared on both sides. A's got to be 15. The coefficients have to match up. There's no way around it. And so they're testing us on this exact same thing here. The coefficients are going to have to match up. I could write it out in a more complicated way, right? If it's like ax squared plus bx plus c, if that equals 15, x squared plus, 31x plus 14, those coefficients are going to have to match up, right? The c value is going to have to be 14. The b value is going to have to be 31. The a value, as we already established, is going to have to be 15. They've got to match up. As long as everything kind of lines up, and you've got the same terms on both sides, then the coefficients have to equal each other. So that's the kind of thing they're testing us on. Anyway, now that you know that concept, we can easily answer this because we know what A and B are going to have to be in all likelihood. Okay? Because I'm looking at this thing right here, and I'm going to, if you're going to FOIL those, right, you're going to get this term. The first term is going to be ABx squared. If you FOIL those. If you know what foiling is, look it up. You're going to have to know foiling on the SAT. So A times B has to equal 15. It's got to. The coefficients have to match up because that's the coefficient in front of the x squared term. There's no other x squared term when I FOIL that on the left-hand side. So A times B has to be 15. But they tell us in the question A plus B has to equal 8. So we got to come up with some values for A and B such that A times B equals 15, but A plus B equals 8. And the obvious answer there is got to be A has got to be 3 and B equals 5, or A is 5 and B is 3. Right? Because you add those up, you get 8, and if you multiply them, you get 15. Right? It's not going to be 15 and 1, right? Because you add those together, you get 16. So, and we don't know which one. We don't have enough, it could be either, right? Which is why there's two possible values for C. So all we got to do is plug in those, those sets of values into the expression on the left-hand side and FOIL it, which we're about to do. So I'm going to plug in a, go purple here, yeah. All right, so I'm going to plug in a 3 for A, so I get 3x plus 2 times, not B, but 5x plus 7. I could have done it the other way around. I could have made A equal 5 and B equal 3. It doesn't matter, and we're going to find the right answer either way. But we're plugging those values in for A and B into the expression. Now we're going to FOIL it, right? So that's firsts. So we get 15x squared. That already matches up with the coefficient on the right-hand side. Outsides, we get 21. When you multiply that, 21x. Insides, that's going to be 10x. Again, this is just FOILing. Look it up on YouTube if you don't know what I'm talking about. Plus 14, that matches as well. Matching coefficients. Hey, so we get 15x squared plus 31x plus 14. I know what our C value is. That was the coefficient they're asking us to solve for here. That C value is the coefficient in front of the x term. Our C value is going to be 31. And the only answer choice that has a 31 is answer choice D. So it's answer choice D. If I plugged in the 5 for A and a 3 for B, right here, this set, then I think I would have gotten 41 for the C value. So anyway, just matching coefficients. Basically what they want to do is kind of rearrange things so that you can easily match up the coefficients on both sides of the equation. And that's what they're testing out when they give you something complicated on the left-hand side and something complicated on the right-hand side. You got to kind of rearrange it to match those up. That's question 15. Let's blast away. Blast away? Let's move to question 16. Hopefully that will load for me. At some point here, we're losing valuable time that we don't have on a 25-minute test here. Oh, I don't even need that page. There we go. Okay, question number 16. I love this one so much. This one's so crazy easy. So if t is greater than 4 and t squared minus 4 equals 0, what's the value of t? Just look at this on a basic logical level, man. You got some value being squared, and you got to take away 4 from that. You're going to get 0. Just think in pure logic. You don't have to do this fancy operation here, right? We know what t squared is going to have to be, man. T squared is going to have to be 4, right? So what is t going to have to be? T is going to have to be 2, which is greater than 0. So that satisfies the requirements of the equation. There's the answer. That's it. It's that simple, man. Don't complicate it. Nothing fancy. Oh, the SAT is not nearly as bad as everybody thinks it is. It's not. You just got to look at it the right way, man. All right. Question number 17. A summer camp counselor, wants to find the length x in feet across the lake as represented in the sketch above. The lengths represented by A, B, EB, BD, and CD on the sketch are determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet, respectively. That means in that order. So in the same order they list the lines here, like AB is the first one, then that's going to be the first one here. That's 1,800 feet. So I'm going to label that right off the bat. That's 1,800 feet. EB is 1,400 feet. That's the next term. EB is right here. That's 1,400 feet. BD is 700 feet. Yeah, there's me. 700 feet is BD. Okay, 700 feet. And then CD is 800 feet. I'm just going to label that for DC. So I think 800 feet. Okay, great. And they're asking us for X feet. That's line AE. Right there. Okay, you get fancy and set up proportions. I don't want to do any of that crap. This is drawn to scale. You can use basic visual estimation for almost any SAT geometry question that's drawn to scale. We can do that here. All right. What I recommend doing is using a method I call the bootleg ruler. We're going to do that right now. We're going to use the bootleg ruler. Take a strip of paper, right? Don't tear pages out of the SAT booklet when you're doing this task. But what you can just use your answer document. All you need is a piece of paper with a corner, right? And the key here is we're going to take an unknown value and compare that to known values. Okay, so I'm going to mark off the length of AE, which is X feet, using the answer document on the actual SAT. I'm just using a strip of paper now to simplify it and make it more clear what I'm doing. So I'm marking off length AE. Okay, there, I've done it. Here's A, here's E, so that length is AE. All right, the bootleg ruler, you're going to love it. And then I compare this value to the other known values. So I'm comparing it to AB, for example. I'm comparing that length, and you notice that's smaller than 1,800 feet. But when I compare it to EB, I notice it's bigger than 1,400 feet. So somewhere between 1,800 feet and 1,400 feet. Somewhere in the middle of that, right? And I'm dealing with multiples of 100 here, so the answer is probably 1,500, 1,600, 1,700. Okay, now watch. I'm going to compare it to CD. Oh, yeah. And CD is like exactly half of AE. All right? And if CD is half of AE, CD is 800, then AE, XV, has got to be double CD, which is 1,600. And there's your answer. Bootleg ruler. Keep it simple. Use visual estimation for geometry on the SAT. I've got some strategies in some of my videos for dealing with non-drawn scale questions, but anyway, if it's drawn scale, just use basic visual estimation. Keep it simple. Use the bootleg ruler if they're testing you on lengths. Let's go to question number 18. I'm going to have to do some algebra here. So we got system equations here. According to the system equations above, what is the value of x? All right, we're going to do the elimination method here. There's no other way to do this with plugging in values. I mean, you could try. It would take forever just to pick and set the values. We're going to do some algebra. So the nice thing about systems equations is that you can add and subtract equations just like you can add and subtract just like anything, right? As long as everything kind of lines, all the variables line up, and we can do that. And they're begging us here to use the elimination method. I'm going to subtract these two equations. I'm going to subtract the bottom equation from the top equation. Subtract the terms. And that's going to eliminate the x variable. I know they're asking us for x, but we're going to be able to solve for y really easily here. And once we know what y is, we'll just plug that y value into one of the equations, and we'll find what the x value is. It's going to be real easy. All right, so I'm going to subtract these equations here. Like x minus x, well, that's nothing, so don't worry about that. That's gone. Y minus 2y is going to be negative y. Okay? Because remember, y is the same as 1y, right? And you're just subtracting the coefficients. And then negative 9 minus negative 25, that's tricky here. That's the same as negative 9 plus 25, which is the same as 25 minus 9, which is going to be 25 minus 9. It's going to be, wait, 25 minus 9 to 2. 25 minus 10. Is that, oh, I'm having a brain fart. 25 minus 10 would be 15. So 25, 16. 16. Positive 16. There we go. No calculator section, everybody. No calculator section. Great. So negative y 16. So y equals negative 16. Great. We know y is negative 16. So just plug that into one of the equations. I'm going to pick the top one because that's going to be easier. So I get x plus, not y, but x minus 16 equals negative 9. I'm going to isolate x by adding 16 to both sides. Plus 16. X equals, that's 16 minus 9. X equals 7. Bingo. There's your answer. Woo! All right, little algebra there for you. Sometimes you got to do it in the SAT. Not a ton. I would argue like 4 to 5 times maybe on every SAT. You got to carry a specific algebraic operation. The rest of the time, you plug in values to the variables, like I'm showing you. All right, question number 19. Hey, trigonometry, fun. In a right angle, one angle measures x degrees where the sine of x equals 4 or 5. What's the cosine of 90 minus x? Super, super scary looking question. It's trigonometry. But if you know SOHCAHTOA, and you should know SOHCAHTOA if you don't know SOHCAHTOA, freaking look it up. All right, that's about all I got to know for trigonometry on the SAT. All right, you got to know SOHCAHTOA. I'm going to write that out for you real quick here. SOHCAHTOA. All right, it tells you what your sine and cosine tangent equal in terms of the length of the side of a triangle. Okay, so because they tell us that, well, sine using SOHCAHTOA, we know sine of x equals OH, right? It's the opposite over the hypotenuse. Again, look up SOHCAHTOA if you're not familiar with it. That's all you need to know for trigonometry in the SAT. The sine of x is the opposite over the hypotenuse. Okay, so we can draw a triangle here, a right triangle. It tells us it's a right triangle. Okay, I'm going to call that x degrees. Here's my 90-degree angle. And it says the opposite, well, the sine of x is 4 or 5, so the opposite side of x is 4. So that's the side opposite x, right? It's literally on the other side of that angle, right? And then the hypotenuse is 5. There's only one hypotenuse in a right triangle, so that's 5. Alarms should be going off here. You're like, oh, we got one side 4, one side 5. It's going to be a 3, 4, 5 right triangle. They love testing on 3, 4, 5 right triangles on the SAT. They just love it. You're going to see lots of 3, 4, 5 right triangles. You're going to see lots of multiples of 3, 4, 5 right triangles in the SAT. Be on the lookout for it. Okay. I don't think we even needed to solve for that value there. I mean, you could use the Pythagorean theorem if you wanted to, but again, just assume, you can assume that you're going to see a lot. It's probably going to be a 3, 4, 5 or a multiple of that. Anyway, so now they're asking us for the cosine of 90 minus x is what they're asking us to solve for here. Okay. You need to know that 90 minus x is kind of code for the other angle in the triangle, the one that's not x and the one that's not 90, right? Which kind of makes sense, right? Because you find the sine and cosine and tangent of angles, right? So 90 minus x is going to be an angle. Well, we know one angle already is 90. We know the other one is x, so it's probably the other one, right? And it makes a ton of sense, right? Because if you know every triangle has 180 degrees, if you know 2 of the angles in a triangle, you can subtract the 2 known angles from 180 degrees, and you'll find the remaining unknown angle, right? So if you've got 180 degrees in a triangle, you subtract 90, and you subtract x, you're just combining like terms. You get 180 minus 90, that's 90, minus x is the remaining unknown angle. This guy up here is 90 minus x. Has to be. All right, there's also like a trig identity thing of knowing, but just logically you can kind of work it out. It's got to be the other angle. Anyway, all right, so we're trying to find the cosine of 90 minus x, so we can use SOHCAHTOA again. We can use the CAH right here. And we know the cosine equals the adjacent over the hypotenuse. Getting a little bit messy there, sorry about that. The adjacent over the hypotenuse. So the cosine of 90 minus x is going to equal, what's the adjacent side of 90 minus x? Well, it's not the opposite, that's 3, it's not the hypotenuse, the adjacent is 4, over, and then the hypotenuse is still 5. So there's your answer, 4 or 5, which, by the way, is hidden in the question again. They freaking love doing it. If you're just guess the values they give you in the question. They do it all the time. They think they're smarter than everybody, and they love dangling the answer in front of you, and you're not getting it. The writers of the SAT, they can matter some time, but you can use it to your advantage now that you see the pattern. And if you're just guessing something, guess the value they give you in the question. Or just be aware, because it's a trigonometry question, we're talking about the ratios of sides, it's probably going to be some ratio of 3 and 4 and 5. So guess 4 or 5, or guess 3 over 5, or 3 over 4, or something like that. Some combination of 3 and 4 and 5 would be smart to just guess. But here again, it's the value they give you in the question. You see that in a number of the practice tests. They make the exact same value that they give you. All right, question number 20. We're going to have to do a little bit of algebra here, but it's no problem. If a equals 5 times the square root of 2, and 2a equals the square root of 2x, what's the value of x? So this is actually a system of equations. It's not super obvious, but they give you the value of a, right? It's 5 over 5 square times the square root of 2. So I'm going to plug that in for a. So it's 2 times not a, but 2 times 5 times the square root of 2. And that equals 2x. Try to find x here, okay? Okay, oh, sorry, that's the square root of 2x. Yikes, okay. Which, that's a little bit complicated now because that x is trapped. It's trapped inside the square root sign. So we have to liberate it from the square root sign. We're going to liberate it by squaring both sides of the equation here. Now this looks really silly, like what's the operation? Whatever. Just think about it. What does it mean to square something? It means to multiply it by itself, right? So we'll start with the right hand side. The square root of 2x times the square root of 2x is just going to be 2x. Right? These guys cancel each other out. When you square a square root, you basically get rid of the square root sign. So the right hand side is 2x. And same with the left hand side. It just means multiplying by itself twice. So it's 2 times 2. Well, let's combine like terms here. 2 times 5 first is going to be 10. So it's 10 times the square root of 2. But it's 10 times the square root of 2 times 10 times the square root of 2. I'm going to combine like terms. That's going to be 100. And the square root of 2 times square root of 2. Remember, that's the square root of 2 squared. So the exponent cancels out the root sign. That's just going to be 2. So 200 equals 2x divided by 2 divided by 2. X equals 100. There's your answer. And that's section 3 SAT practice test number 1, the no calculator section. Not quite in time, but fast. Thanks for watching.